Welcome to our webinar. Thank you for joining us today's Minitab webinar. Topic is Minitab Statistical Software, Predictive Analytics. I'm Nur Sulawati. I'm the Technical Support Specialist at Visit System. Visit System are independent and representation of Minitab in Singapore, Malaysia, and Batam, Indonesia. So before we get started, there are a few skipping items to take note. If you have questions during presentation, please type them into the question box in your control panel. You may send in any time throughout the presentation, but I will address them during Q&A session and then our webinar. Kindly ensure that if you have connected to audio via your computer speaker, please fill out our survey before you exit the tab. This survey will help us to improve the quality of our upcoming webinar. For your information, this webinar will be recorded and therefore it will be set listen only mode to avoid interpretation to the audio recording. The recording will be accessible anytime later on our website www.visit.com or by subscribing to our YouTube channel, Minitab Malaysia and Singapore. Okay, for those new with us, Minitab Statistical Software is a software package for statistical analysis, and as I think we not only have a Minitab Statistical Software, we also have other software like Software Predictive Modeler, Minitab Connect, Quality Trainer, Minitab Workspace, and Minitab Engage. But today we just focus on the Minitab Statistical Software. Okay, so basically we are nearly 50 years in the market. So, but we start from the three professor from the Penn State University, and then after that we grow, and today almost 100 most of our customer in this world. Okay, not the only Singapore, not the only Malaysia, but almost all the country in the world be our customer. Okay, so this one is example the features inside the Minitab statistical software itself. For let's say you coming from the quality side, so we have a measurement system analysis, our MSA, we have control chart, we have capability, we have the acceptance sampling or tolerance interval. Also, if let's say you are coming from the reliability engineering, we cover also, and we have a tools inside the reliability engineering. Okay, and then here is for the R&D, maybe for design of experiment. We not only have a full factorial, we cover all others design, something like response surface, mixture, Taguchi, and so on. And then I think today most of us talk about the analytic. So Minitab also have we call it the business analytic, something like we have a correlation, and then new updating for the Minitab 20.3, we have something like correlogram, the new visualization help you to identify the correlation between X and Y variables. Okay, and then inside the business analytic, we have something like regression modeling. We have a multivariate modeling. Okay, we have cluster analysis, and then today we rely on the tree-based learning, or we specific for the classification and regression tree. Okay, let's say your data in the time series order, we also have a time series analytic. We have a ARIMA model. Okay, and then here is something like for the process validation. We have 3 stages in the process validation. So we have a process design, we have the process qualification, and then we have a continued process validation. So since we have covered almost all type of the analysis, so our customer also coming from the various sectors, manufacturing. In manufacturing is a big field, so we have electronic, we have automotive, and so on. Also, we cover for the services industry, and then we also have the academic sector. Okay, so today is our agenda, something like, I think this one is most of us talk about the predictive analytics right now, because we have something like big data, we have a lot of historical data. Okay, so today we focus on the predictive analytics available in the Minitab Statistical software also, and then we go for the some basic for the predictive analytics, we call it validation. And then we go for the tree-based method. Inside the tree-based method, we have a cut model, classification and regression tree. And then I go for the random forest, and then I go for the Treenet. Okay, for manufacturer, machine downtime can cost millions of dollars in year, a lost profit, repair costs, and the lost production time for employee. So by applying the predictive analytics, hopefully manufacturer can monitor the condition and the performance of equipment, and then predict the failure before they happen. So this one is I think uh, is a most important term here is you want to do the prediction. So all the inside this method will help you to do the prediction model. Okay, so we go for the predictive analytics. So predictive analytics combine the use of the data. We have a statistical algorithm, and then we have a machine learning technique to predict the future outcome based on the observation data. So which is you have your data. So inside your data, you have features or something like we have variables. Okay, and then from the combination of these variables, you can get the model. So after you get the model, you can go for the prediction. Okay, whether that's why it's here, you can get the insight from the our data. So data can be a variety, maybe in numeric data, text data, or so on. So in the features, maybe not only from the one machine, maybe combination of the all machine. So you can get the features, and then you combine all together, you do the modeling side. So we have a lot type of modeling, or we go after this one by one. Okay, and then from this model, actually you can get more insight here. For example, you want to predict. For example, here I'm the new one, want to buy the new house. Okay, and then I need have a data. Okay, something like area of my house, my budgeting, my income. So from that attribute for the variables inside there, I get the models. So something like before this, we always using the regression. So we get the equation from the regression, and I try predict with my income right now, with my how many room I want, so I can get the value of the house. So that's one is how we want to have the predictive analytic. Okay, so collection of algorithm. Algorithm is a refer for the model with a high accuracy that allow us to make the prediction for better decision. So now we not only focus on the find out method inside the predictive analytic, but most important here, we want also have the high accuracy, because we want to do the decision from this prediction. Okay, so predictive analytic maybe can help you answer this question, something like you want to, what are the key drive that influence the need for maintenance on a machine. So you want to the variables, what is most important thing, okay, impact to your maintenance or to your machine, or impact to your downtime. Okay, so or what are the root cause of defect in my process. So something like almost I think almost all of you face it with the defective, how many defect you accept. So always have about the defect. So you want to find out which factor are most important into your defect. Okay, and then maybe you have which your potential customer are mostly like to respond to a credit uh, or to a credit card offer. So something like you want, if let's say you are services, you want to find out your customer behavior. Is it after you do the something marketing event or what the offer? So is it they can buy it or not? So something like that one is a predictive analytic. Help you do the prediction because you want to do the best decision maker. Okay. So this one is the something like generally predictive modeling workflow, often involve this step. The first thing, you need to find the business problem. I think almost of you know about the PDCA. So something like the you need to plan it. So you need to have a define your business problem. After you define the business problem, as example, I want buy a new house, okay, and then I need to gather the data, okay, so I need to go to maybe Google's and site area in this Kuala Lumpur, basically how many average which part, okay, how many type of house we have. So I need to have information or gather the data, and then I export it and then I prepare the data. Maybe in the real life, maybe you want to combine it, and then you need to find out the relationship between variables you include in this information. Okay. After that, from the combination of the variable, you need go further, create the models. So here is attached on the mathematical model, something like maybe a regression, maybe logistic regression, maybe you can go for the card classification and regression tree. Maybe you don't need to do something like supervised, maybe you can go for an unsupervised method, something principal, component analysis, and so on. So you can create the model here, okay? And then after you create the models, you need to access the model, okay? This part is different type of the model. You can get different type of measurement or matrices. But I think most of us familiar with the R squared. So we rely on the R squared. You see how much percentage the variability explained in for the R squared. So you need to compare. If let's say you have a model, okay, something like regression or cut, so you rely on the R squared. After you rely and that R squared, and then you can choose it, which one is the best model. Okay, after you get the best model, and then you can deploy the result. Maybe you do the prediction. So from the prediction inside there, you can get something like insight, something like okay, this range of the value of house, okay, from the 50K, maybe okay, 100K or 1 million K, this in this area, and then how many room you have, and so on. So you can get something like insight in your data. Okay, so hopefully they can get the objective of this predictive analytics. So this one is how the flow we to do the predictive analytics. I think almost of us, and then if let's say you are coming from the quality background and then process engineer, whatever, familiar with the PDCA, same thing like PDCA also, but different term only. Okay, the mechanism is the stay the same. Okay, so before we create the models, something different between the traditional way compared to predictive analytics is we call it validation. Okay, so validation is to prevent the building models with low predictability. In the validation, we have a two process, which is we have a training where you learn data to create the model. Okay, and the other portion we call it the test data set. So you want to do to validate your data set. So in the differences between traditional and the predictive analytics is here. It's a validation where you split your data set into two portion. The first one is we call it training data set. Training data set where you need to create the model, you build the model, and then the test data set you assess the data set, okay, to assess the modeling, okay, from the huge of the data set. Okay, maybe traditional way we assess our data set with the new coming data set, but for the predictive analytics we do the validation part, okay, where we split into training and test data set. But for the splitting into training and test data set, we have a method inside there. Okay, for example, we have generally several methods, but here I just focus on the three term. Okay, three type of splitting of our data set. Okay, the first split is a leave one out, cross validation, and then the second one is we call it K-file cross validation, and then third one is we call it validation with a test set. And then for information, all these validation type are in our tools. Okay. Before this, I think we cannot see the. Sorry, I go to Minitab first. Okay. In the before this, we cannot see it in the regression. Okay, regression. We try it. Okay, so we have a validation here. Okay, so validation here we have the K cross validation and validation with a test set, or you can go for the regression. You can go for the binary logistic regression, also available for validation part. Okay, we have a K cross validation and we have other validation. We are the test set. Okay, so also we have the for the cut. Okay, so we have a cut. And then we have the option here. Okay, so in the card also have the validation. Okay, something like, okay, so you can have this with a test set. We have a K4 cross validation. So all these type are available in the Minitab. Okay, I think starting with the Minitab 19.3. Okay, so why we need the validation? Because we want to some avoid to the overfitting. Okay, so we have here is the example model with the fitted data set. Okay, the same model, but with the new data set, you can see that this line is above or below this point, not the fit with this one. So as we know, to get the high accuracy of this one, you need to have a fit this in this data set. Okay, even for the new data set coming. Okay, so this one is why we need the validation. So to do the validation, we have several types to do the validation. But maybe some trigger part, if let's say you are small, some sample size, you can use it for the leave one out cross validation. Or if let's say you have moderate amount of data set, we can go for the K-fold cross validation. And then if let's say we have a large data set, you can go for the validation with atas data set. Okay, so for the which leave one out, basically is something like the algorithm cycle through all the rules of the leaving out a single observation at the time and refitting the models. I think this one is most of us know about regression. So this one is most type you can see it in the regression. Okay, and then the second part is a K4 cross validation, which is you have 100 data set, you split into K fold, K group, maybe 10. So every in the data set, so you choose 9 from the 10 group, be the training data set, the left one as a testing data set. And then you can repeat again up to 10. So you can go for the K full cross validation, or you can go for the validation with a test set. Okay, so maybe you have 100, 30% is the testing, 70% to build the model. So this one is how we split our data set. Okay, so this one is a model, okay, predictive modeler are available in the Minitab. As we know, machine learning, we have concern about the two, split into two, supervised learning and we have unsupervised learning. What I mean by supervised learning? Supervised learning means that you have your output or you have your Y. Okay, so we consider that is a supervised learning. If let's say your aim just only to group the data set, to group the variables, so we call it the unsupervised. You doesn't have any Y output. Okay, you doesn't have any target output. You just want to see the classify or grouping your variables only. So for the supervised learning, we are available for linear discriminant analysis. We have a quadratic, we have logistic regression, and then the new starting with the 19, we also have the cut classification tree, or we call it cut classification tree. Or we have the Y. If let's say your Y is a numeric data, okay, you can go for the simple regression. Okay, you can go for the polynomial regression. You can go for the multiple regression. You can go for the non-linear regression. You can go for the PLS. And then you're also available for the tree-based method. Okay, for if let's say for the cut regression tree, we have include in starting with the Minitab 19.3. Okay, so if let's say you using the Minitab 19.3, okay, so you able to run the cut regression tree. And then this one, the random forest and the Treenet is a separate module. Have an additional cost to get this one. Okay, additional fee if let's say you want to do the random forest and the Treenet. Okay. So I have one example here. I think it's a simple example only. Okay. Okay, so the cardboard manufacturer wants to use the past data to assess the relationship between potential predictor and manufacturing costs. So to determine the predictor have most impact on the manufacturing cost, and then after that they want to do the predict manufacturing cost for each customer order based on the potential predictor. So they gather the data, okay, the variables, or we call it the features. So they have a predictor, is a style, the plan, segment, and so on. But the response or the target of Y is a cost of manufacturing. So I think I go to the Minitab directly, okay, for this data set, okay. So in this data set, actually, you can go further for information. Okay, so you have the 4 variables. Okay, for predictor is a text data set. Okay, is a T here is a refer to text data set, and then you have say 6 variables. Okay, a numeric data set. And then you have your Y or your target here is response. So you can see it that all this one. Okay, so you have a style inside style, because style is the text data set. You have level inside the style. You have plan, you have segment, we have a market, weight, speed, rate, efficiency, setup, time, MTL, and then we have a cost. Cost is our target. So we gather all these variables. Okay, we gather of these variables to see the relationship between the costs. Okay, for example, weight with the cost, speed with the cost, rate with the cost. After know the relationship between these variables, they provide, they need to build the model or to create the model. After create the model, they want to do the prediction. Okay, so this one is the purpose of this predictive analytics. Okay, so we go to start. Okay, we start with the regression. Okay, we start with regression since our Y is a numeric data. And then for information, not only one variables, but we have 10 variables here. So we need go for the start regression, we go for the regression, we go for the fit regression models. Okay, so we choose with the cost. Okay, so the rest is we are continue. Sorry, cost. Okay, so I just only proceed with this, and then you click OK. So you can see it that this one is a regression question. Okay, so this one is our interview. So we want to see the R squared. So, okay, we want to see the R squared here. So the first thing you see it, the R squared. So I think it's quite good. Okay, it's a quite good 82.84%. So the R squared is quite good. But if let's say you see it, this equation is made horrible. Okay, something like I want to the, as we know, the good model is the simplest model. Simplest model meaning that is a less number of predictor inside here. But now you see that this equation is so horrible. Okay, to do the prediction after this. Okay, so it's make nightmare. Okay, you can handle it, but it's something like nightmare. And then another thing is in the regression side, we have to need to check the assumption. Okay, you need to check the assumption. Okay, so if let's say you see it, the assumption here is something like, okay, you see it there. So as we know, must be a straight line because we want to the residual is normal distribute. But now it's something like it's not normal, and then you have outlier here. Okay, also you have your outlier here. So we can proceed with this regression, but have a lot of time to do a lot of technical part. You need to do it. Okay, you need to do it to handle it. This one. Okay, so that's why in the Minitab we won't try it to solve your problem. Okay, with the tree-based method. Okay, so the tree-based algorithm utilize a series of if-then rules to create prediction from one or more decision tree. Okay, so the tree-based method empower predictive analytics with not only speed the answer, but they provide frequently accuracy and easy of interpreting. Honestly, I think for me, it's a cut is easy of interpreting. Okay, and then a cut compared to linear regression, like linear model, like regression, tree-based machine learning, it provide more. If let's say you have more non-linear relationship, is more better. Okay, if let's say you want to visualize or your data is a little bit messy. Messy meaning that is you have a missing of value, you have outliers. So tree-based method is appropriate for the kind of the data set. Okay, as we know, if let's say you have a lot of missing data, so if let's say you proceed with the regression, is something like you need have some time, okay, to handle it. And the regression least square method is not good handle for missing data. You need to remove your data. Okay, you remove the data for the missing and the outliers. But in the tree-based method, they not worries about the messy data, no worries about the missing value, no worry about the layer. They can handle it. Okay, they can handle for the tree-based machine learning. And then for information, for the tree-based method, they doesn't have any assumption. Okay, you no need to check in the assumption, not looking to the residual must be normal, and then your residual must be independent. No need. So you just proceed with the tree-based method. So we highly recommend, if let's say you do the regression but it's not work well, so you can go for the tree-based method. Okay, you can go for the tree-based method. But in the tree-based method, we have a tree algorithm inside there. The first one is, we call it classification and regression tree, or we call it the CAT. And then the second one is, we call it random forest. Okay, and then we have a Treenet. But the random forest and Treenet, you have an additional fee needed to subscribe the predictive analytic model. Okay, so we go for the cut first, because if let's say you want to know about the random forest and then Treenet, you need to rely on the cut first before you go for the random forest and then Treenet. Okay, so basically, cut or classification regression tree is a split. Okay, splitting the response, our Y variable, into partition based on the predictor or your X setting. So you can split our data set, okay, by the split the response into the partition based on the predictor X setting. But as we know, data type have a two type, is a continuous and attribute, or text data or numeric data. So since go for the cut can go for the numeric data set. Cut also available for the classification data set. So the cut can be to both sides, whether your Y, your response is a numeric, or your response is the classify. So you can able to use the cut. Okay, so I want to say here, cut no model assumption. Okay, no need to check the model assumption. So model follows the data. Okay, not the form, the line. Okay, maybe easy to interpret. We go after this, and then is a more suitable for medium to the larger data set. If let's say small data set, I think better go for the regression rather than cut. Okay, so but if let's say you have a big data set or large data set, you can go for you can try cut model. Okay, so this one is some terminology before we got further. So all this one is, we call it the nodes. Okay, the nodes. And then here, the top one is, we call it the root node. Okay, and then inside the root node, the splitting here, okay, the splitting here, or we call it the decision rules, okay, define how the node are partitioned. So for example here, we have weight less than 396.5, so you go for the left. If the big, for the right, or yes or no, you go for the yes, go for the no. So small, big, so you can go another splitting here. So we have a go and split. But to do the splitting, we have a technique inside there. So the technique inside to do the splitting, okay, we can also using the least square method as a regression method. Okay, so the tree splitting, when the data partition, this tree has a two splitting. The first here, okay, the second is a split here. So in the last one, okay, in this one, we call it terminal node, where the node has no sub branch, so not split again. So here we call it terminal node. In the terminal node, you can get the prediction model. Okay, maybe here we have a mean as a prediction value. Okay, so that's why we need have a terminal node, because in the terminal node, you get the prediction value. Okay, so first you need to know the nodes, how many nodes you have. Okay, how many terminal node you have, because inside the terminal node you can get the combination. Okay, you can get the combination. The first node here is coming from the weight less than 396. The second terminal node here is combination weight more than 396.5 and speed less than 16. So you get this terminal node, or you get this mean. And then we have a third terminal node. Okay, so you have a third combination, you get this value. So simplify that. If let's say you're looking for the prediction small value, okay, so you can go for this combination. If let's say you want the biggest number of prediction value, you can go for this combination. So this one is, if let's say your card have a big number of terminal node, so you can get more decision row, okay, on that inside there. So this terminal node is important because you want to know the combination, and then inside the terminal node you have the prediction value. Okay, so for example here, okay, cut can be treated as a collection of the rows. Okay, so rows 1, terminal row 1 is the weight is a less than 396.5. The predictor value of manufacturing cost is a 79.02. So same with this rows 2, and then same with the rows 3. So you imagine now, if let's say you have a 10 terminal node, so you have a 10 rows. So from the 10 rows, maybe you want to segregate by less number or big number or range from where to where. So you can get the combination. How they get this value combination from this predictor, this value of the predictor. Okay, so we try to cut regression tree. Okay, we try with the Minitab. Okay, so I go back. I use the same data set, but different model. Okay, different model. This using model, we using the cut. So where you can get, go to stat, go to predictive analytics, you choose regression, cut for regression, since our cost is the numeric data. So here is a cost. Okay, so this one is a rate. Okay, this one is categorical predictor. So basically, if let's say your data are more than 5K, so the default setting go for the validation with the test set. If let's say your data less than 5K, the default setting for this validation go for the K-fold cross validation. So I just proceed with this default only. Click OK, and then click OK. Okay, click OK and click OK. You get this note. Okay, this cut analysis. I go back, you go to stat, you go to the predictive analytics, you go for the cut regression. So you need to identify the response variable, your predictor, your categorical predictor, and you click OK. And then you get the cut. Okay, you get the cut. So if here is we have a 30 nodes, meaning that now in your mind, you have a 30 terminal nodes. You have a 30 rows. Okay, you have a 30 rows. So you can go for the R squared here. So seems because cut for regression also seems that you need looking for the R squared. Okay, you need to looking for the R squared. So here is our 3. Here is our 3. So maybe you can go for here, select alternative 3. Okay, so you looking that this one is optimal R squared. Okay, so you can go for here. So from this value for R squared, 0.83 is quite higher rather than regression just now. Okay, and then you have a terminal node. Okay, we have a 30 terminal node. And then using all the predictor. Okay, using the all predictor. So inside here, you can see it that, let's say you want to find out the highest mean. So you go for this one. So you choose the highest mean. So you see that this one is the highest mean. Or you can go here. Maybe you want to the lowest mean. okay, the lowest mean. They provide the 5 highest, they provide the 5 lowest, and then they provide the optimal nodes. Okay, so it depends on your objective. Okay, maybe for this case, you go for the lowest one. This case, maybe you go for the big number. Okay, so you can rely on this one. And then for information, if let's say you're not satisfied with this tree, so maybe you can go for the smallest tree. Okay, you can go, okay, grow up. Okay, and then you can see that your R squared is has something like increase. Okay, increase the R squared. Okay, increase the R squared, but have different terminal node. So basically, we're looking for the optimum only. Okay, but you can choose based on your preference, whether you want to choose with the two maximum R squared and so on. Okay, so here, so you satisfied with this one, right click, and then you want to have the lowest mean. Okay, so you can see it that here, okay, you can get the combination of this one. Okay, or I think I like it this one. Okay, so they give it the combination. For example, I want to choose this one. This one is the terminal node 6. Terminal node 6 is combination from this weight, okay, this weight, and then this rate, and then this weight. So you can copy for clear up this one. Okay, you can copy it. So they give it you interesting part. So you can see it this one. Okay, with the mean, with the standard deviation. Okay, and then the most here is R squared. So you can see it. Not the only R squared, maybe you rely on the MSE, or you rely on the MED, or you rely on the MAPE. And then the most important here is we want to know what from the 10 predictor, which one is the most important effect to our manufacturing cost. So it's our weight here. It's a most important variables. Okay, so you get this weight here. Okay, so here also we have a fitted, but you see that training and the test set is something like the same pattern. Okay, the same pattern. Okay, and then so from here you've satisfied with the 30 nodes, and then you can do the prediction. Okay, but as we know, for this predictive analytics, we need try and error. Which one is the best one? We compare the R value here. Okay, we compare the R value here. So for this case, our R value is 8.3. It's quite good. Okay, it's quite good. If let's say you want to proceed with this model, so you can get the prediction value from this model, from this 30 terminal nodes. Okay, so the 30 terminal nodes here. Okay, so from the 30, you want to assess more about this terminal node. You just rely on the less number of this one. Okay, 5 less number. So viewing the terminal node, so the process condition led to the lowest mean or target manufacturing is the terminal node 6. So you compare with the 5 terminal nodes. So the terminal node 6 is a less number, and then this one is combination. Terminal node 6 is from the weight less or equal to 8186, and the rate is more than 10.8. Okay, so you can go one by one. Okay, so this one also take. Okay, so after you get the card, maybe you stay wondering why we need have the predictive analytic model. Okay, because our aim to do the prediction and predictive analytic is looking for the high accuracy. Okay, high accuracy. So purpose of the statistical models, we have a y equal to fx plus error. So error here is a refer to understanding the variation and accurate the prediction. So type of the error here is looking for the variance and bias. Okay, if let's say you go for the model complex for the variance, so you can get the most complex if let's say your variance is big. But now for this one, we want to get the balance model. We call it the balance model between bias and the variance. Okay, so we want to the balance model. So how to get the balance model? Maybe we need to have something like multiple cut, okay, or we call it here is assemble models. Okay, we want to try to minimize the variance while having the bias remains the low. Okay, so we have something like bagging method to reduce the variance, or boosting method to reduce the bias, or in specific way, bagging method for Minitab, we're using the random forest model. If let's say for the boosting, we're using the Treenet model. Okay, so what is the random forest? What is the Treenet? Okay, so random forest, okay. So random forest is combination of the cut. Okay, combination of the cut. You imagine cut, you have a tree. Inside the tree, you have a terminal node. So now for the random forest, actually you want to combine that tree. Okay, you want to combine the tree. So they using the bootstrapping sampling. Okay, bootstrap sampling something like you have 100 data set, you take one, and then you do the modeling. After that, after finish, you throw up again into your data set. Okay, and then you maybe you can choose it the same data set again. So this one is we call the bootstrapping. How they want to have a lot of cut, so they provide the random forest. So from the bootstrap one, they provide the cut one, okay, cut two, and so on. But if let's say your Y is classification, you go for the majority rules. If let's say your Y is a regression, you need to average of this rule. So you can get result for the random forest. Okay, so I think I just go for this one. Okay, so if let's say you subscribe this additional cost for this predictive analytic module, you can get seems like me. Okay, predictive analytic model. Inside the predictive analytic model, you can get cut, you can get Treenet, you can get the random forest. But we try with the random forest first. Okay, so the same thing with the cut, you need to have identify the response, your predictor, continuous and categorical predictor. So I just proceed with this default only and then click OK. Okay, click OK. Okay. Okay, so this take some time. Okay, so here is our response. So here again, your R squared, because this one is a regression. So from here, you can see it that the R squared is increase to the 94.33%. So if let's say compare with this cut, you can get more accurate for the random forest. Okay, and then the variables important here stay the same. Is the weight. We are the best predictor into this example. And then you can see the scatter plot here. And then if let's say you are satisfied with this model, okay, with this model, you can do the prediction. Okay, but it's not just like a cut. You can see it, the combination. Okay, you can see these three. In the random forest, you cannot see the tree because in the random forest is combination of the three. Okay, it's a combination of the three. So you can rely on the R squared. You can get the variables important here. Okay, so we go for the next thing is the Treenet. Okay, Treenet is something like starting with your residual. Okay, from your residual, you build the cut. Okay, you build the cut, and then you multiple with the, we call it learning rate. Okay, we call it learning rate for every cut here. So basically, Treenet is cut. Treenet is a tree from the residual. Okay, so they combination all these one, and then they get the cut. They get the Treenet. But most of a 30 models here, Treenet is high accuracy model. Most high accuracy model since they using the residual. So refit the model, refit again, get the new cut, new tree, and then they sum of this one. So you can get the Treenet. But this one is, we have another thing here, is rely on the learning rate here. Okay, learning rate. Okay, so I think I go to this one. Okay, I using the same case study again. Go to predictive. Okay, go for the Treenet. Okay, fit the first one. Okay, the same stat. Okay, different algorithm only. Okay, and click OK. Okay. Okay, so now you get the Treenet. Okay, Treenet. So you see it that the R squared again. Okay, and then you rely on the R squared. It's quite higher rather than random forest. Okay, 96.18. And then the most important variable is also the same, is a weight. Okay, so you have a scatter plot here. And then the more important here is, if, let's say you're using the Treenet, they provide you the partial dependency plot. Partial dependency plot, or we call it PDP plot, is something like inside here. So you see that if, let's say, you want to our weight is increase, okay, increase. So you see it that the cost of manufacturing also increase. So you can see something like information, more information. You, if let's say you're using the Treenet, something like, if let's say you are coming from the design of experiment, so the one is something like optimization. Okay, so you can see that if, let's say, the weight is high, the cost of manufacturing also is high. Okay, and then you see it that for the rate. Okay, so if, let's say, increase of the rate increase, so the cost manufacturing is a decrease. So maybe you can get something like range in here. Okay, something like in range in here. Also for this one, as a speed increase, decrease, and decrease. Okay, so all this you can get if, let's say, you're using the Treenet. Okay, the differences between random forest and the Treenet. Treenet has something like, we call it partial dependency plot. Okay, one is how to evaluate how the changes of the key predictor variable affect to our response value, or useful for the controlling the setting that enable optimal the production outcome. So I think if, let's say, you're familiar with the min plot, okay, the function is something like the same. Okay, so you won't see that the rate, if, let's say, the rate increase, what happened to our cost. Okay, our weight is increased, what happened to our cost. So this one is the Treenet. Okay, so from this, from the three, from the four model here, so we need to compare which one is the best one. Okay, which one is the best one? Okay, the best one. So since regression, we cannot fulfill the assumption, so I just put here is our cut random forest and the Treenet. So from based on the R squared here is Treenet is the best because have the highest accuracy of the prediction. So maybe from the Treenet model, so you need go for the prediction. Okay, you need go for the prediction. So from here, okay, so from this one, from this model, okay, from this model, so you go for predict. Okay, you go for the predict. So after you justify the four of this model, so you choose based on the R squared, Treenet is the good one. Okay, so you can go for the prediction. Okay, you can go for the prediction. So for example here, okay, prediction. Sorry. Okay. 32, 0. So you imagine now you get the new data set coming. You get the new data set coming. Okay. I try it only. No, this one. Let's see. 4. Okay. 5.3. Okay. So here maybe this one is the retail. I'm trying it narrowly. Okay, this one. Okay, and then you click OK. So now you get the prediction for the cost. With the setting, you get the value of this is a 100 predictive value. Okay, so this one is how you do the prediction. Okay, how you use or you apply the predictive analytic. So from here, basically you can get more insight here. Okay, or something like I just using, okay, I go. So I go for the Treenet again. Okay, so I just proceed with this one, and then you want to storage, you want to see it the predictive, so you just fit, click OK, and then click OK. So they generate to you. Okay, so you see it that here is the predictive value. So every combination here, you get the predictive value. So from here, maybe you can go for the heat map or whatever. So, and from here, you can get more insight from this predictive value. Okay, so you can get more insight. For example, here I just proceed with this one with the heat map. Okay, so graph is a fit. Okay, so I just want to see the style. Okay, by variables. Okay, segment. Click option and click OK. Sorry. Okay, sorry. Wait. Then click OK. Okay, so you can see it that this one is the segment, or you can see that the mean. So you can rely one by one of this one. So this one is how you get the insight after you get the predictive value. So you can get this something like one. Okay, so you get this one. Take away. Okay, sorry. Okay, so if the relationship between your x and y variable is well approximately by a linear model, so you're using the linear regression. If let's say you have a high non-linearity between, you can go for the Treenet. But if you're going to build a model that is easy to explain, a decision tree or tree model, will be almost always be a better choice. Okay, we are. So if let's say you have any question, you can type into the chat box or question box. Okay. So if let's say you want to this training, you can drop your email and then I send after this. Okay, beside the R-squared, can I analyze using the p-value? For this case, I'm not sure, is it you refer for regression or you refer for the cut? If let's say for the cut or for the tree-based, we doesn't have any p-value. Okay, we doesn't have any p-value. If let's say you want to assess the variable predictor, they rely on the variable important only. For the cut, if let's say for the regression, you can rely on the p. Is it significant or not significant? Okay. Okay, can you please elaborate small, medium, large data set, or how many? Basically, it's the small, medium, large data set. If let's say for Minitab trigger, if let's say less than 5K, we consider that using K for correlation. If let's say more than 5K, you using the validation with a test set, but we doesn't have any fixed number. Okay, it's a depend on you, because the number of the data set not only consists of the number of observation, maybe rely on this how many variables you also have. Okay, how many variables you also have this one. Okay. Others question? Okay. Others question? If let's say you interest on this one, okay, on this portion, we have, if let's say you want to learn more about this, maybe you need have something like training. Okay, we have a course free applicable to our customer. If let's say you purchase the predictive analytic model with a busy system only. Okay, so our registration deadline is 50 September. But if let's say you want to know more or want to more, you can visit our website www.minitab.com, or you can contact us. Let's say you want to ask about the card, about the predictive analytics and so on, or you want to see the more on this one, so you can contact us to sales@visit.com, or you can contact or email us to minitab@visit.com, and then you can follow us through the media social, Minitab Malaysia and Singapore, or in the link Minitab Malaysia and Singapore. Okay. Okay, is the Treenet run all the data set? Yes, Treenet run all the data set. Okay. Treenet run all the data set. Okay. Others question? Okay. If let's say doesn't have any question, or you have others question, you can email us. Okay. You can email me, or you can email to minitab@visits.com. So thank you guys. Stay safe, and maybe we see you again in different topic.